Good morning everyone, it's me Chandrakala here. In last class we have seen some basic physical quantities and some basic units. So as we have discussed that initially we have found three basic units for length, mass and time. So we will define them in detail, only three, that is for length, mass and time. So we will start from length. First of all we will start from the units of length. So SI unit of length is meter. This is our first work. As I said, in physics we will be working with SI system. So our first work is we will have to write down SI unit of our physical quantity, that is meter. Now next thing is, what do you mean by 1 meter? See, in physics whenever we will define any unit we will have to give a definition for it. So if we are saying that the SI unit is meter, then the next our duty is what is meter. So for meter, initially very earlier one definition was given. We will learn one that and one recently, not very recently, but which is most important for right now. So we will learn two definitions for meter. The first one, which was given in 1889, was that first I will write some words from the definition, then we will explain it. Distance between two marks. Distance between two marks on platinum iridium rod at 0 degrees Celsius, placed at International Bureau. Okay, these are some words written in our definition. That means what? That means actually 1 meter is defined as distance between two marks on a platinum iridium rod. We know that platinum iridium means it is an alloy. Okay, so an alloy is there made up of platinum iridium and two marks on it. Suppose this is that rod made up of platinum and iridium as an alloy, and we are having two marks on it, one mark and second mark. Distance between both these marks is known as 1 meter. Actually this alloy is, or this you can say, this rod is kept at International Bureau of Weights and Measures at CBO near Paris. That means we are having an international bureau at Paris. There we have kept a rod made up of alloy of platinum and iridium, and two markings are there on that rod, and distance between both these markings is considered to be a standard 1 meter measurement. That means with the help of this platinum iridium rod, if we will make some meter scales equal to length between both these marks, then that meter scale will have a measurement of 1 meter length. Okay, then we can make the copies of that 1 meter scale and we can use it. Okay. Next thing is, here one important word is written, that is 0 degree Celsius. Why it is kept at 0 degree Celsius? This whole rod is kept in the bureau at 0 degree Celsius because we have learnt about expansion, or you can say heating effect of substance, or you can say heating effect of materials. When temperature of any particular material increases, then that particular material will expand, whether that is a solid, liquid or gas, whatever it is. On heating, metals or materials expand, or you can say substance expand. Similarly, on cooling it, they will contract. So obviously if this distance will expand, then it will be more than this and our measurement will become inaccurate. Similarly, if due to decrease in the temperature there will be contraction in it, then the distance will get reduced and that will also make our measurement inaccurate. So just to keep it constant, just to keep it standard, we have kept this platinum iridium rod at 0 degree Celsius, because at 0 degree Celsius the material will be in its own natural state. It will not be expanding and it will not be contracting. So this 0 degree Celsius word here has much importance. Next thing you can consider why the platinum iridium only, because we have already learned many things about silver, gold and platinum, and maybe now also you are learning about them in chemistry. So since just from the a point of view that the rusting should not be there and any other quantity or any other disturbing factor must not be there, so from that point of view we have selected platinum iridium, which will be affected minimum by all these things, that means the moisture, or you can say due to rusting, all these things. So especially here we have to remember platinum iridium only, this we cannot change. Similarly 0 degree Celsius is also compulsory to write down, because if the temperature will vary, then there will be expansion and contraction in the rod, which will vary the measurement, and the measurement will become inaccurate. Okay, so this is first definition for 1 meter. Okay, one more definition is given for 1 meter, that is given in the terms of speed of light. Okay, so 1 meter is defined as the distance traveled by light. Actually speed of light we will use later. So the distance traveled by light in 1/299799245 of a second. Okay, in air or vacuum. Only important words I have written, rest of the things you can see from your book definition if you want full definition. See, we are having this one definition, that is at International Bureau, one platinum iridium alloy rod is kept, 2 markings are there on that rod, and distance between those marking is considered as standard measurement for 1 meter. From there we will take the measurement of 1 meter, and then accordingly we can use it. We can use a smaller value, that means we can decrease its value and we can increase its value using prefix. This we have already seen in the last class. Now the next thing is, our next definition is, we will define according to speed of light. See, first of all 1 meter, we know that 1 meter is the unit of length and distance is also a length. So 1 meter is the distance traveled by light. How much distance is traveled by light in this much of a second? In mathematics you have learned the meaning of off. Off means multiplication. That means we know the timing 1 second, how much is 1 second, and we have divided that 1 second by 299792458. Okay, which is also approximately this value we take equal to, for easy numericals, that is, which is equal to 3 into 10 raised to power 8 meter per second, and we are familiar with it. It is nothing but speed of light, but actually this is not the real value. Real value is this 299792458. But for easy calculation in numericals we use a speed of light which is equal to 3 into 10 raised to power 8 meter per second. Okay, we know that speed is equal to distance upon time, therefore we will say distance is equal to speed into time. Here we are explaining it in terms of speed of light. So speed of light is taken as 1/29979922458 of a second. Of a second means multiply by 1. That will not make any difference. If you want to write down, you can write multiply by 1. Okay, so how much answer you will get here, that will be equal to 1 meter distance. Okay, so these are two definitions related with meter. Okay, at any one, for now you are having choice, whatever you feel easy, anyone you can write down in exam. Okay, now we have to see some subunits of meter. That means we will see other units of meter. So first we will see subunits, that means the smaller than meter, and later we will see actually multiple units. Okay, so our next topic is, we will see subunits of meter. Okay, now already we have learned the prefix, so it's not very difficult for us. We already know the first one given is centimeter. Okay, centi prefix was there, and here we are learning about meter, so we will keep here meter. Okay, centimeter, and we know that 1 centimeter is equal to 10 raised to power minus 2 meter. This we have already learned when we learnt the prefix. And the second one is milli. I'm writing in short now, you will do it by yourself. Milli means 10 raised to power minus 3. Here we are talking about meter, so I will write down here meter. And the third one given is micro. Okay, for micro we have learnt 10 raised to power minus 6 meter, and the next one is nano. Okay, nanometer, that is equal to 10 raised to power minus 9 meter. That's why I told you at least some prefix we will have to learn. So now separately we don't have to learn anything. If you need to convert it into kilometer, you know relation between kilometer and meter, but generally in exam they will be asking in meter only, because meter is the SI unit of length. So these are some smaller units related with meter. Now we will see some larger units also. So the first one given is kilometer, and we already know that 1 kilometer is equal to 1000 meters, or we can say 10 raised to power 3 meters. Two more prefix we have learned, mega and giga. If we will need, we will use them. Okay, now some non-metric units, that means units of the length only, but non-metric. Non-metric means they do not depend on meter for their derivation. However, we will learn its relation with meter because our SI unit is meter. So we have to learn a relation between them, but technically from their definition and to find them we do not need meter. So they are known as non-metric units. These are some larger units because we are learning multiple units only. So some larger units, but they are independent of meter. So the first one given here is astronomical unit. So for definition we will say that this is the distance between sun and earth, or you can say earth and sun, whatever you want. Distance between earth and sun is known as 1 astronomical unit. And now we have to remember its numerical value. 1 astronomical unit is equal to 1.496 into 10 raised to power 11 meter. Okay, as I said, we will have to remember its relation with meter because meter is our SI unit. So we have to remember this numerical value as it is. And for definition, 1 astronomical unit is the distance considered, that means the distance between earth and sun. See here in this chapter, most of the things we will be learning with respect to sun, but we can also relate them with other stars also. But since about sun we are having sufficient information, so we will be using sun. Okay, sun is also a star. So generally when we are saying sun, sun means we are talking about any star, and here especially we are talking about sun. Okay, this is our first work. And our second unit is light year. As the name indicates, light year, it is the distance traveled by light in 1 year in vacuum. This word actually we should have discussed earlier also. Okay, so 1 light year is the distance traveled by light in vacuum. Distance traveled by light in vacuum. Earlier also we used this word vacuum or air. See, speed of light we have already seen, that is 3 into 10 raised to power 8, approximately 8 meter per second. And how much a distance that light is covering in 1 year, actually in 1 year, that is equal to, that much distance is equal to 1 light year. As we are saying that the distance traveled in 1 year, and 1 year is a very long time, so obviously the distance which we will get here will be actually a large value, and obviously we are learning multiple units of meter, so it should have a large value. Next thing, this vacuum and air. See, when any particular light ray passes or travels through a medium, then it has different speeds in different mediums. So as a standard we are considering the speed of light in vacuum, because the speed of light is maximum in vacuum. That is what we were saying, 3 into 10 raised to power 8 meter per second. That is possible only in vacuum. Okay, if we will pass it through any other particular material except vacuum, then it will slow down. Okay, that we will learn later in refraction, reflection. But right now, earlier also this word came vacuum or air, so I think I should tell you. So vacuum means, because we are giving a special condition that the light is traveling through vacuum only, because if it will be traveling through other medium, then its speed will change. Next thing, sometimes instead of vacuum, word air is also used. However, they are not same, but since the variation in air is very less, so we considered it equal to vacuum only. But technically vacuum and air are two different words, two different definitions. Vacuum means completely vacuum, nothing is there. Nothing is there means air is also not there. That means any gaseous molecules or anything is not there, that is known as vacuum. Whereas air means it is already having a mixture of gases, that is known as air na. So obviously there the speed of light will not be same in vacuum and air, but approximately, because much variation is not there. So sometimes you may get, not only in this chapter but in other chapters also, you may get the word vacuum and air simultaneously. So please make it clear. Okay, so now we have to again one light year, we have to learn its relation with in terms of meter. Obviously that is 9.46 into 10 raised to power 15 meter, that is 1 light year is equal to 9.46 into 10 raised to power 15 meter. This we have to remember. All the numerical values we have to relate with meter, so these we will have to remember. But even if you forget by chance at the time of the exam, then you calculate it from our same formula, that is speed is equal to distance upon time, and here we are learning finding distance. These all are the units of length, and distance is a length. So distance is equal to speed into time. Now we are saying that speed, we are talking about speed of light. So speed of light is approximately 3 into 10 raised to power 8 meter per second. And time here we are saying it as 1 year. Now you know that 1 year will have 365 days, 1 day will have 24 hours, and 24 hours means 1 hour will have 60 minutes and 1 minute will have 60 seconds. So if you will multiply them by these numbers, first we are multiplying by 365, and 1 day will have 24 hours and 1 hour will have 60 minutes and then 60 seconds. Likewise you will get your answer in meter. So but see, this calculation will be very lengthy, so as much as possible we will remember this directly. But in case if you forget by chance, then you can use this method, that's all.